Yep.
The broadcast is now starting. All attendees are in listen-only mode.
Thank you everyone for joining the New Eagle webinar today. We're going to get started now. This is New Eagle vCAN Data Logger, and my name is Ben Hoffman, and I'll be doing kind of an overview and then passing it over to Steve to talk about the data logger and to do some demos and some development. So the agenda for today, this is the 7th monthly webinar on our data logging tools, and we're going to do an overview and then an introduction to the data logger and some demos, and we'll talk about a new product that we're starting to develop for working with the system data, analyzing the data, and doing some simulation and kind of overview of our data logging system, which we're calling OWL. So during the webinar, if you have any questions, there is a question panel as part of the GoToWebinar interface, and you can ask questions there. If we see a question that is topical to what we're talking about, we'll try and answer it during the webinar. If not, then we'll answer questions at the end. So feel free to add questions whenever something comes to mind. So the data logging tool that we're going to talk about today is part of our platform for developing control systems. We have a team that develops products and components here at New Eagle, and we also have a team that does applications development. And so as part of our applications development, we have the need for a lot of different tools and processes. And so as part of our applications work, we find the need for different tools, and we create those tools and offer them also to our customers that are developing control systems. So what we call that platform is Raptor, and it's controllers and components along with tools and processes that we've engineered to work together that are intended to allow you to rapidly develop control systems. So to develop a full control system, you have to go through many different stages, and we go through this process for our applications development, starting with the concept development through rapid prototyping, design, validation, all the way through fleet management and service of a system. And so we have processes and tools that work with our components and controllers at each step of the way. And today we're going to talk about the data logging tools that are used towards the beginning of the system lifecycle, and those tools are used as your beginning development and also as you're kind of validating that your system works appropriately. So the Raptor platform has tools that are used throughout the system lifecycle, and today we're going to talk about this one in the middle, data loggers, both the PC data loggers and the embedded data loggers that we have. There is a data logging component to our telematics, and we covered that in a prior webinar. Today we're going to focus on this middle line here and talk about the tools that we have for use during system development to analyze data, capture data, and even to create simulated data. So what we're calling our data logging platform is OWL, and you can do data capture on many different data logging appliances. As I said before, you can capture data at the top here with the telematics platform. So, you know, this is when you're kind of in a fleet testing mode, we'll say. Some people do it during earlier in the process, but if you can consider maybe you've got 10 vehicles in the field and you're collecting data with a telematics appliance, That data would be sent to a central repository in the cloud, and you'd need to be able to recover that data and analyze it. So we've got the OWL tool allows you to pull the data in and convert it into a more useful format for analysis. But if you're earlier in the development, you may want to use an embedded data logging appliance, and that's the middle one here, or the PC, where you're actually physically connected at all times with your PC to the system. And regardless of the logging appliance that you're using, it would be useful to be able to look at the data in the same way. So if you've built scripts or any analysis tools, having the same format of collection, the same output format from the logging appliance, is useful so that you can create common tools that you can use regardless of the logging appliance. And so that's kind of what we're attempting to do with our OWL tool. And you can see on the left here, you use the industry standard CAN-DBC file and a configuration tool to configure any of the data logging appliances, and there's a universal output format that allows you to write common scripts or analysis tools to work with the data that you've collected. So with that, I'll turn it over to Steve, and we'll talk about our VCAN data loggers.
All right, thank you, Ben. So the VCAN data loggers, we have the 320 and the 800. Both support USB data logging to the USB stick up to 64 gigabytes or more. And we have two products. So two ways we can do data logging, which is through the VCAN 320 data logging product or the Raptorized VCAN 320 with custom data logging. And we'll show you both of those today, but we'll start with the productized data logger. So this is the basic I/O of the VCAN 800. If you haven't seen it before, it's touchscreen, analog inputs, outputs, two-channel USB or two-channel CAN, RS-232. Similar for the VCAN 320, we have analog inputs, outputs, 5 touch buttons instead of touchscreen. Also data logging to the USB stick. So I'm going to show you our PC simulator tool for the data logger, which is the equivalent of running it on a computer without a USB stick. So this is the state you would see in a when you first power up the USB, or you first power up the VCAN without a USB stick in it. It says logging is inactive, and you can add a USB stick and it'll start logging, and then you'll get some other screens like if I have any here. I don't have any. But the other screen's indicating that logging is active. It'll give you some stats of how much space is being used, different modes you're in. So it also does analog input logging instead of just, in addition to the CAN channel logging. And it has some neat little features like this CAN analysis tool for stats and looking at CAN data as it's coming in. So there is a configuration menu on the, this is the productized data logger. So there's a configuration tool to change the baud rates, to set the type of mode, so you can stop it when it's full or you can continuously log. And then there was a future request to limit the size of the logs, and that's so that you can analyze the data better afterwards in Excel or whatever your tool is.
So this this logging product is it's a physical display that we've configured with a program, and you can see the circular buffer here. You could use this as a black box where it sits on the system, creating circular or creating log files, and like if you've got the log slot size set to 8 megabytes, when the USB stick is full, it will delete the oldest file so that it can create room for a new one. And that way, in like a black box type of scenario, you'll have the most recent 16 gigabytes of data at any time when you pull out the USB stick. And you can do configuration right here for, if you've got multiple baud rates. The VCAN 320 logger has 2 CAN buses. The less expensive VCAN 320L only has 1. So you can these are available on our web store, and work with any CAN bus, just putting the raw data onto a USB stick.
All right. So let's see. We went through the configuration of that tool. We looked at the screens. We could do an example, or we could jump into Raptor here. Let's jump into check the presentation and do the Raptor logging demo. So the goal here will be to do a ground up from Raptor data logging project to log a simulated signal from our OWL tool. We'll call it the engine speed, and when that reaches a certain value of 3,000 RPM, we're going to trigger on our data logging, and then we're going to log for 30 seconds and put that to the USB stick, and then we'll pop that out and put it into my computer, and we'll analyze the data with the OWL tool. But before we do that, we'll do a demo of the productized data logger here using the OWL tool. We'll get you familiar with it quick, and then you can see how that works with Raptor.
So first, we'll take a look at if you were to buy the VCAN data logger product off of the website and use it as is. You've got the menus that Steve showed in the simulator. Those show up on the physical display, and what we'll do is we'll go ahead and we've got one on the bench here. We'll use our CAN simulator to send out some CAN messages, manipulate the data, and then pull the USB stick out of the back of the display, put it into the PC, and then open the log and run it through the converter so that we can get some Excel data.
All right. So step 1 with the OWL tool is to add a DBC file to our simulator. We will use this aprop message, and we're going to find the where is it? The engine speed signal. Engine speed. And we will start simulating that by clicking the button, and you can see that we have some CAN messages going on there. And I think we're on the wrong baud rate, that's why we're getting an error frame. So I'm checking my CAN connection here. There we go. I had a disconnected cable. Okay. So we're sending the 71 message, which contains our engine speed. And it looks like the value is changing as I change my slider here. So that part of the signal testing is set up. So let's go, hold on one second.
So before we go on, this tool here, OWL, is a tool that we're developing to work with it's part of the data logging platform, and you can see here, in order to create some data for our use here, Steve is simulating a CAN message. Where we've got a CAN King window there that you can see the raw data on the bus. He loaded a DBC file which is specifying all of the CAN messages, and then he's using the slider there to manipulate one of the fields inside that message.
Yep. So to start with the data logging, I need to plug in a USB stick into my vCAN hardware setup. So I'm going to do that. And I'm going to make sure I have the right file on there. Am I logging on it? And it has the USB log offload.ars. So we plug that into our vCAN, and you won't be able to see this. But on the the hardware setup, it says USB stick inserted, space free, 740 or 7,400 megabytes, logged data 0 megabytes, logging active, some other statistics. Yeah, I have the. It might appear in the PDF here. No. Okay, so back to the OWL tool. We're simulating our message. We can add a bunch of other messages if we want. They should all be picked up by the data logger, physical data logger. And I'm looking at my vCAN, and it says log data is now at 0.1 megabytes. So that means we picked some stuff up. So I'm going to go ahead and disconnect the vCAN, or the USB stick from the vCAN, and plug it into my computer. Alright, so it drops it into this logs folder. 0012 is the newest log. So CAN1 is the channel we want to look at. So we'll take that and copy it over to our working directory. Delete the old one here and paste it in. And we'll take a quick look at it just in Notepad here so that we have data logging. So we have our CAN IDs, we have data coming across. So let's analyze that. Or we also have our inputs channel we can look at in CSV format. And that's also, we see 14 volts for the VCC or analog channel 0. Let's take a look at the CAN1 in our OWL tool.
So that input CSV was the physical inputs to the display. So if you wanted to log analog inputs or I guess any of the other digital inputs on that, those show up in that file.
Right. So we have our OWL tool open again. We can analyze our log by adding a DBC file, which is the one we looked at earlier. It'll pick up all the signals in it, and we want to take a look at engine speed, which is the one we were simulating earlier. And we take the log file and the logs here, and we convert it to CSV. And that'll allow us to get some nice graphs in Excel. So you see we have our two signals here, engine speed and engine coolant temp. We weren't changing the value on the engine coolant temp, but we were on engine speed. So if we graph this, we should see some data changing. And you see it's kind of yeah, maybe the chart type I used wasn't that great, but it does change from 3,000 down to 2,500 up to 3,500. So do a run chart, you say? Where do I do that? What do I want? This.
So we have the off-the-shelf logger that we just looked at. That's a display that we send out configured with the data logging application, and it can be used as we kind of demonstrated here. Now, if you're already creating a display using Raptor, you can add data logging to it with our the access that we provide in Raptor to the USB port, or if you need to have kind of a niche data logger that provides custom triggering or something, and you want to build it yourself, you can do that using the Simulink environment and create your custom logic. If you've got DBC files, you can pull in a message. We'll kind of show that. You can pull it in to the software with the DBC file in the model, and then you'll have the engineering signals, and you can use the blocks, USB blocks, to write them to the USB stick. So you can kind of create your own custom embedded data logger appliance in that way.
All right. So we are in MATLAB now, and we're going to look at the Raptor tool. So to start us off, we do a Raptor create display project, give it a title, It's going to load up a template project for us, which will include the data logging, and we're going to make our modifications to that data logging portion to get it to do what we want, which is trigger on receipt of a EEC1 J1939 message, which contains our RPM data, and when that goes above a certain value, we'll trigger and start logging. So looking at the CAN logging, we have a log channel CAN1 and log channel CAN2. We want to look at CAN1. So we're logging everything on CAN1 standard, logging everything on CAN1 extended.
So we just created a template project for one of our displays. And inside the template project, there is basically a data logger that's very similar to the one that we demonstrated in that's the off-the-shelf product. Basically, here we've got a logger for CAN1 and CAN2, and it's putting all CAN traffic onto the USB stick in a file. And so this is can be a good starting point if you're going to be creating any kind of logging or working with the USB stick in a display, in addition to being a starter for if you're going to do display development using Raptor. So the template project contains a lot of good structure to get started in creating a display, whether you're doing a logger or an actual system human interface display.
Right. So to receive the CAN message, we're going to take a look in this plant here. We're going to add a CAN receive message from Raptor, and then we'll reference our DBC file with the EEC1 EEC1 RPM message. So CAN RX. EEC1, we only need the engine speed here. And when that value is greater than 3000, we will trigger CAN logging. And to do that, we have a variable inside our log CAN called logging active. So we'll set that to true. With a Raptor data write. So this will allow us to only log data when RPM is greater than 3000. And I'm just going to mask off some of the bits here in the ID to make sure we get the message that we want. Okay. So logging is active when we receive an engine speed greater than 3000. Let's take a look at the log can real quick. So the header of the file is going to be this right here, which is a extended, the ID, the data length code, the data, which is the MEL format that we use with most of our tools here.
Yeah, you might kind of walk through how this this sample implementation of the logger works. This is very similar to what is done in the off-the-shelf product, and like I said, it provides a good example for how to use these blocks. So you might just walk through how it works functionally.
Sure. So when the USB status is inserted, so the USB stick is inserted, it's going to create a file handler for you. It's going to open up the file. It's going to write the header. Well, it'll create the file first here, or it will open an existing file. And then it'll plug in the header, and then pass that file handle along to your file write functions. So this is a CAN trigger. It triggers on any standard CAN message, and it will log that with a printf statement here. So this is the format of every line on here. I can show you it in the data log we logged previously. So this %x corresponds to the hexadecimal number. Similarly, hexadecimal string for %s. So those all get created there, and then we drop them in with our other blocks over here. And then it all gets written to a file write command, which then gets written to the USB stick. And we have some analysis here with the data read frame write frame count for CAN 1. And similarly for extended messages we do the same thing, but we have a different extended ID.
So where are the USB blocks located if you want to pull them into the model?
Sure. So we have them in our Raptor display library, I believe, or Raptor data logging. We have a whole bunch of USB things here. So the USB status I was talking about earlier. Data log, erase, write, read. The ones that you primarily will need are the write, because you're not really reading from the USB stick, you're just going to write to it. The file sync block handles to, so every 10 seconds we trigger a sync, and that just makes sure that the stuff we have in memory gets written to the USB memory stick. So that's that.
The blocks here support, you can see there's a lot of file-based, file I/O type blocks. You can read, you can seek within a file, you can get the file size, so you can determine if you're filling up the stick. The scenario that we're talking about here is using the USB port on the display as a storage mechanism, but it also could be an input. You could think about maybe using it as a place to put configuration files into the system. So if you wanted to use it in another way, the blocks are there to support workflows other than just the data logging scenario that we're talking about here.
Okay, thank you. So, let's just go ahead and build this, I think. We have our CAN message set up to enable logging once RPM reaches 3000. So we will build that, put it onto the vCAN, and then simulate some messages with our OWL tool to see that trigger, and then look at the data in our OWL tool again and make sure it's doing what we want.
You might talk about the target definition and configuring the compilers for simulator and in the embedded.
Yep. So we have 3 targets that we can target for the displays. We have our vCAN Lite, our vCAN, and then our vCAN 800. So sorry, vCAN 320 Lite, vCAN 320, and vCAN 800. We're going to build for the normal vCAN 320. And you have the option to build for the simulator, which is the PC simulator tool we saw earlier, or this the target hardware. Code Sorcery is our compiler. So we'll do both the Code Sorcery and the simulator. And you have the option here to set the baud rate. 250 is good with us. And we will build away. So we see here that we aren't writing the right type of data. It's a quick fix. We output to a Boolean instead. Okay, our build is done. And if we look at our output in ECU, we should find it in our data logging. Where did it get dropped? So the output is the simulator, which is running right now. It just contains the HMI default stuff right now, quad screen, and a large gauge that are both being simulated right now. Neither of which really apply to our logging demonstration right now. It also includes the zip folder containing our files that we put onto a USB stick to load the new application onto the vCAN. So I'm going to extract those and then drop them all onto the USB stick. If I do that right. Oh. Delete the USB logging offload, because we don't need that. And copy all these files. So again, you won't be able to see what's happening on the physical device, but I will narrate it as it happens. So I just plugged the USB stick into the vCAN, and it should, after I power cycle here, it'll load the new application onto it. So it says preparing for update. Updating, please wait. During this process, it'll load new firmware if it needs to. That's what all these surplus files are for. Your app is contained in the app folder, and then the rest load on new firmware to the vCAN if necessary. So update's finished. Please remove USB stick. So we have on that vCAN now, it has that same application that's running at my computer. So I'm going to delete the files on my my flash drive. Because we don't want to load the application onto it again. We just want to start logging new data. So I'm going to plug that into the vCAN, and we're going to use our OWL tool to simulate data. So I want to make sure I grab the right DBC file. So I'm just going to check the CAN message that we pulled off earlier. So it's using demo area example CAN J1939 EEC1. So we add our DBC, example CAN J1939 EEC1, and let's just verify in CAN it's simulating 0CFF04FE. That's our J1939 EEC1 message. And our mask is set up to accept that. So when we drag this, we can drag it down here, and once we go past the 3000 mark, it should start logging. So that should be enough to check our data logger. So I'm going to unplug the USB stick and plug it back into my computer now. And if all went well, we will have some data to look at. And you see we have two logs, CAN channel 2, which we didn't put any data on, and CAN 1. So this is our raw log, and you can see it's grabbing all the data here. Now I don't think this this format is going to work with our tool. It's just the default quick, ready to go logging format.
Yeah, the format of this log is very similar to CanKing. So if you have CanKing pulled up, the template project basically gives you a CanKing recorder. So if you pull up CanKing and compare this log to the one that is in CanKing, you put that on not fixed positions, I think it looks pretty much the same. So it doesn't match the output from the embedded logging appliance. It's just a CanKing log as an example. So you can kind of see with the Raptor tool you can create a custom scenario if you want. Yeah.
Right. All right, I'm going to try plugging into Raptor here, but I don't know how well, or into OWL. Let's see how that goes. If it's similar enough to the CAN data, or to CanKing, it should be okay. We want engine speed. So it looks like it pulled off some data, but I don't. So I think that format wasn't conducive to our CanKing parser. So if you look over here, you don't see the X to indicate it's a extended message. Yeah, so different formats. In our OWL tool, we're going to keep adding different logging formats support. But if we look at the direct log here, you can see that we're logging all the data. It's just a matter of interpreting that in our very, very new OWL tool. So anything to add, Ben?
Yeah, I think that shows a good overview of how to use the USB blocks with the display and how to implement a custom logging scenario. And typically what people do, since they have the DBC files in the model, they'll typically create a custom format that actually has the engineering signals in it rather than the raw CAN. So if they're you know, the display model's already parsing the CAN messages using the DBCs, and there's engineering value like engine speed and RPM on the bus in Simulink, and so it's a simple matter to send that directly out to the USB stick and put it into a file on there, and avoid the need to work with the raw CAN logs. People usually do that for like if they wanted to implement a freeze frame or something on the logger.
Okay, and with that, we will check if we have any questions over here. Thank you for your attention. If you have any more questions about this, go ahead and contact Ben or I or anyone here at New Eagle. And I'm looking, we just had a question pop up here.
Yeah, so the question is, what is the price range for these devices? The off-the-shelf logger is available on our web store. I don't have the price in front of me, but you can go to neweagle.net and go to the web store, and all the pricing is listed there. And then for the second scenario where we created inside of a normal Raptor model, we created a custom logging scenario. That's just a standard Raptor vCAN display, so there's no additional cost associated with using the USB stick. You have to have a Raptor license and then just a standard Raptor vCAN 320L, which is the lower cost version, or the 320. Or if you want to have the 7-inch touchscreen, that's the vCAN 800, and those are all available right on our web store. So we'll hang out for a little bit in case there's any questions. And you can also, if you have some additional questions, send to support@neweagle.net. Okay, we have another question came in here. What is the integrity of the logs during power cycle? So if you look at our the way that our logger was set up in that example, we had a sync every 10 seconds, and so basically you can be sure that you're not going to lose more than 10 seconds of data when the power is pulled. But the scenario there where we sync, you can Steve, if you want to pull up the sync logic there, where it's determined when to sync. Yeah. So you can see here we just have a time, and when it gets to be greater than 10,000 milliseconds, we go ahead and issue a sync. You can do that however you'd like. If if you want to do it in a controlled way with a relay or something where the device is able to hold power, you can implement custom shutdowns. So it's kind of up to you. It's definitely available in the model to issue the sync whenever you want. And the sync controls when it gets written out to the file. So it looks like that's the end of the questions. Now, if you're interested in some of the display stuff, we didn't really touch much on actually creating screens. But if you go back a couple webinars, you can find the recording of the webinar that we talked about developing the actual display model. It's in the same environment. We had some screens in that template project that showed up on the simulator. Those are kind of a starting point, and you can use those to see how screens are built. There's some pre-built components that we include, like gauges, and in the standard way that a Simulink library block is composed, you can right-click and go under the library block and look at how the graphical elements are used to build something like a gauge. Obviously, with the gauge, you've got a lot of different elements, like the needle is rotating. You've got text that shows the current value. So you can go under and look at how that's done with breaking the link on the library block. And that can be a good example for how to build displays. Now, as we said at the beginning, this is the 7th webinar, so there's a number of other topics that you can look at the recordings. We're going to have another one next month on how to use Motohawk, so tips and tricks. That's a great place if you've got questions. We'll have some of the most experienced Motohawk users around on the webinar, and they can answer questions. And they'll also present some tips and tricks. So that's next month, November webinar. So thanks for joining. It looks like we don't have any more questions, so we appreciate your attention here, and look forward to hosting you again next month for another webinar.